Okay, so we were talking about Mendel's laws in the last video, and we're going to focus in on the law of segregation because that's going to lead us into monohybrid crosses. So the law of segregation actually describes the inheritance of one single characteristic. So his hypothesis to explain the 3-to-1 ratio that we saw in the last video of the F2 generation was that the F1 generations were all have a hybrid, he said hybrid, we would say heterozygous genotype. Remember, the genotype are the genes present or the alleles, okay? And heterozygotes are one uppercase and one lowercase letter. Now, last time we talked about probability. And we did a Punnett square without realizing we were doing a Punnett square. And a Punnett square basically shows us the possible combinations of alleles, okay? So I'm going to show you how this works. Now, the parent generation in Mendel's explanation were, remember, true breeding, which means they were either the purple were all had 2 dominant alleles and the white had 2 recessive alleles. Then the F1 generation, because the only possibility for the purple flowered dad to give is a dominant allele, and the only possibility for the white flowered mom to give is a little p, all of their offspring have to be big P, little p. And if we're going to do a Punnett square, we can do that right now. This guy's got a big P, little p, little p. We're going to cross them. So first I drop down my dominant trait. Okay, I always put my dominant allele first. And then the recessive trait across. And we can see that we have 100% probability of having heterozygotes, big P, little p, all right? Which, because big P is dominant, will all look purple. So their phenotype will be purple. Phenotype is purple. And their genotype is heterozygous, okay? Now, if we are going to take these purple plants and we cross them with each other, the mom purple plant can give either a big P or a little p. And the dad plant can give either a big P or a little p, okay? So now this makes things a little bit complicated because if we drop down this big P right here, then we pull this big P over, we have one big P, that's homozygous dominant. All right? Then we have one heterozygote. But as you can see over here, we actually have 2 heterozygotes. So these 2 are heterozygotes, or big P, little p. And then we have one homozygous recessive. So the genotypic ratio is 1-to-1, or you have a 25% chance of big P, 25% chance of little p, and a 50% chance, that's the 2, of big P, little p. Now, what are they going to look like? Remember, phenotype, what are they going to look like? All 3 that have the big P allele, no matter what, are going to look purple. So I do not like this, the way they do this, 3 purple, but this is a ratio, 3-to-1. You have a 3-to-1 chance of having a purple flower. But I like the law of addition, which is this is 25%, 25%, 25%. So this is 75% chance of purple and a 25% chance of white. These chances reset with each offspring. Okay, with each offspring, you have an equal chance. All right. So homologous chromosomes bear the alleles for each characteristic. So every diploid cell, that's, remember, 2N, that means you have 2 alleles, has pairs of homologous chromosomes. The chromosomes in a homologous pair carry alleles of the same gene at the same location. So, an individual that's heterozygous for a gene, according to the law of segregation, each gamete formed by this individual will have either a big B or a little b. Duh, right? That's all they have to offer. Which step in the process of meiosis is the physical basis for this segregation? So if you go back and you think about meiosis, you think about how we took that cell with two alleles in it and we separated that out. So that's going to be a meiosis 2. I would say probably anaphase would be the most technical definition of that. Okay. And this is just showing you that the gene that, let's say this is dad over here and this is mom, the gene you get from your dad and your mom, they are going to be located at the same place on the gene. That's what on the chromosome. That's what makes them homologous. Okay. So what we just finished doing was a monohybrid cross. A monohybrid cross is for one characteristic. So for instance, we just did flower color. Okay. Now a dihybrid cross, which we'll do in the next video, is 2 characteristics. So if we did flower color and leaf color, that's 2 different characteristics. So Mendel said, hey, he also came up with the law of independent assortment. This says that alleles of a pair segregate independently of other alleles. So when we get to this dihybrid cross, we're going to see this play out a little bit. In other words, purple flower, just because a parent has a purple flower and a yellow leaf, doesn't mean that they travel together on the same chromosome, right? So his law says that the purple flower is going to separate independently of the yellow leaf. So 2 traits are going to separate independently. All right. Now, what if you get into a situation where you don't know what the genotype of the parents are? Okay. So if you have a parent, all right, you are going to do a test cross. And a test cross is mating an unknown with a known. And the only way you can really know what an individual is if they are recessive, because recessive, you must be homozygous. Okay. For a recessive individual, you must be homozygous. So I'm not going to do this one because I'm going to let you do this one on your own. But I am going to do our purple plant. So let's say we have a purple plant. Now we know that the purple plant must have at least 1 big P. We know that. But we're not sure whether it has 2 big P's or a big P and a little p. However, if we made it with little p's, all right, we mate this person with homozygous recessive, so a white flower, okay, then we know that we should get at least 50% of them purple. Now, if this is a big P, all right, so this is a question mark. If this is a big P, then they're all going to be purple, right? However, let's erase this right here. If this is a little p, then we should expect to get we should expect 50% or thereabout to be white and 50% to be purple. All right? So when we cross them, when we cross these guys, then we will know, is this parent, if all of our offspring are purple, then most likely that parent is homozygous dominant. However, if we get any white offspring, then we know that parent had to have donated a little p. Therefore, he is heterozygous. Okay? So now this is, we're going to look at one more monohybrid cross before we finish the video. So this is an unknown. We don't know the genotype of this black dog. He could either be heterozygous or he could be homozygous. So homozygous dominant or heterozygous. And the only way to know is to cross him with the brown dog, which is homozygous recessive. And so we know that if all of our offspring are black, then this guy is big B, big B. If we get a couple of chocolate or a couple of brown labs, then we know that that's little b. Okay? So now it's time for you to work on some of these on your own.